Hello students, welcome back to another video. In today's video, we'll be doing remaining questions of paper code 0625, May June 2024, variant 1. Starting from question number 6, it is saying figure shows an isolated metal sphere suspended by insulating thread from the ceiling. So here we have a ceiling on which we have suspended a sphere. The sphere is negatively charged. The charge on sphere produces an electric field in its surroundings. State what is meant by electric field. So electric field is a region where an electric charge experiences a force. Second part says draw on figure 6.1 to show the pattern and direction of electric field produced by a charge on a sphere. Draw at least 4 lines. So for negatively charged particle, the electric fields are towards the charge and they should be equally separated. The B part says the magnitude of the charge on sphere is 3.5 into 10 raised to power negative 10 coulombs. An earth metal wire is touched against the surface of the sphere and the sphere is discharged. State what happens in the wire as the sphere is discharged. So we are connecting an insulating wire and grounding it, and all the negatively charged particles will start flowing towards the ground and the sphere will get discharged. So sphere has negative charge, so electrons flow through the wire to the earth. Second part says it takes 0.14 nanoseconds for the sphere to discharge completely. Calculate the average current in earth wire as the sphere discharge. So time is 0.14 nanosecond. We have to calculate the current. And we know the charge in the sphere was 3.5 into 10 raised to power negative 10 coulomb. And the time is 0.14 as it's nano. So I'm multiplying it by 10 raised to power negative 9 seconds. Current is defined as charge passing in unit time. So charge is 3.4 into 10 raised to power negative 10. Time is 0.14 into 10 raised to power negative 9 seconds. So current is 2.5 amperes. Next question is saying the electromotive force of battery is 7.5 volt. Define the term electromotive force. So let's suppose we have a circuit on which we have a lamp. When 1 coulomb of charge leaves the battery, it has full energy, and when it reaches, let's suppose here, some of its energy would be lost in form of heat. When it crosses the lamp and reaches over here, most of the energy would be lost in heat energy and light energy, and when it reaches to the battery, almost all of its energy would be consumed in one complete round trip of a circuit. So it is work done by 1 coulomb of charge in moving around a circuit. B part says the battery is connected in series with variable resistor and a 30 ohm resistor. The battery is made using 1.5 volt cells. Draw a circuit diagram that shows all the 1.5 cells connected to produce an EMF of 7.5 volts, the variable resistor and 30 ohms resistor. So we have 1.5 volt cells and we need the voltage of 7.5 volt. So how many cells we can combine to reach the voltage of 7.5? 5 cells would be needed. So a circuit would look like this: 30 ohm resistor and a variable resistor connected in series to it. The second part says the resistor of variable resistor can be varied from 0 ohm to the maximum value of 150 ohm. So this resistors can vary between 0 and 150 ohm. Before doing the further question, let us just discuss the maximum current and the minimum current in the circuit. The current in the circuit would be maximum if the total resistance of this series connection is minimum. So putting in the values, the voltage is 7.5. Now how can the total resistance be minimum if this resistor has the resistance of 0 and this is 30? So the combined resistance is 30 ohm. Then the current would be maximum value, which is 0.25 amperes. Now how can the current have its minimum value? The current will have its minimum value if the resistance is highest, total resistance is highest, then the current would be minimum. So putting in the values, the voltage is 7.5. Now what is the maximum value of resistance? If this resistor has the resistance of 150 and this has the resistance of 30, then the maximum total resistance would be 180. for which the minimum current would be 0.041 amperes. So this is the minimum current in the circuit and this is the maximum current flowing in the circuit. Now we can do our next part. Using the axis in figure 7.1, draw a graph to show how the current in the circuit varies with the resistance of the variable as it increases from 0 to 150. Determine and label the value of maximum current on the circuit. So on y-axis we have current and on x-axis we have resistance of variable resistor. So if the resistance of variable resistor is 0, then the current is maximum, which is 0.25 ampere. And if the resistance is maximum, which is 150, then the current is minimum, which is 0.041. So current is maximum at 0 ohms of variable resistor and current is minimum, which is 0.041 at the value 150 ohms of variable resistor. So I have marked 2 points and there is a reverse relation, inverse relation, so the curve will be like this. Question number 8 says the isotope of thallium-208, which has 81 atomic number and 208 mass number, is radioactive. It decays by beta decay. The thallium-208 decays to an isotope of lead. Complete the equation for this decay. So this atom is going to decay a beta particle or an electron and it will form a lead. And electron has -1 charge over it and over here we write 0. Now we will balance the equation. 81 this side, what can be added to -1 to make it 81? So 82 minus 1 would be 81. What could be added to 0 to make 208? So it would be obviously 208 and the equation has been balanced. Now the second part is saying the beta emission of thallium is accompanied by gamma emissions from the nucleus. Explain why this gamma emission does not affect the numbers in the equation. So as you know, this equation is also going to emit a gamma particle. And why the emission of gamma particle would not affect this equation? Because gamma particles are uncharged and massless, so it would have no charge over it, so it will not affect the equation. Third part says suggest one reason why nucleus of thallium-208 is unstable. So if we see the atomic structure of thallium, over here we write number of proton and over here we write mass number. That means this atom has 81 number of protons and 208 subtracted 81 is 127, which is the number of neutrons present in it. So this thallium surely has more neutrons, that is making it unstable. B part says a sample of thallium-208 is placed in thick lead container. Figure 8.1 shows a narrow beam of beta particles and gamma radiation emerging from a small hole in the container. So here we have a sample of thallium-208 which is emitting gamma and beta particles which are going straight into magnetic field and the direction of magnetic field is into the page. The narrow beam entering a region where the magnetic field that is directed into the page on figure 8.1. Draw a line labeled B to indicate the path of beta particles in the magnetic field and draw a line labeled Y to indicate the path of gamma radiation in the magnetic field. So first thing first, as you know, gamma particles are chargeless, so they will not be affected by magnetic field and they will travel straight into the magnetic field. But the beta particles are negatively charged and as their direction of flow is towards right, that means current will be flowing opposite to the flow of negative charge. So the current would have this direction. So using Fleming's left hand rule, so if current is moving in this direction, you will use your middle finger towards this left side of the page and you will use your forefinger and will be directed this finger towards the page. That would represent magnetic field and you'll see your thumb will direct downward, which will be representing the direction of force on these negatively charged particles. So downward force will deflect the beta particles in this pattern. Ninth question says the sun is one of many billions of stars in the Milky Way. The sun emits a very large quantity of energy as electromagnetic radiation. The three regions of electromagnetic spectrum in which sun emits the most energy. The radiations that are coming out of sun having the maximum energy are ultraviolet radiation, infrared and visible light. But why not they are gamma and X-rays? Because gamma rays that are produced by sun are immediately converted into lower energy light and they are not able to escape the sun. So the highest energy radiations are UV, infrared and visible light only. P-path says electromagnetic radiations from sun travel at the speed of 3 into 10 raised to power 8 meter per second and takes 500 seconds to reach the earth. Calculate the distance between the sun and earth. So we have time, we have speed and we need distance, and you know the formula is distance is equals to speed multiplied by time. Speed is 3 into 10 raised to power 8 and time is 500 seconds. So the distance is 1.5 into 10 raised to power 11 meters. CPAT says approximately 4.6 billion years ago, the sun formed from an interstellar cloud of gas and became a stable star. Describe and explain what happens to an interstellar cloud of gas to form a protostar. So let's suppose this red ball is a cloud of gas and it has its gravitational attraction towards the center of the cloud. So, when this gravitational acceleration increases and becomes stronger, the temperature of the cloud increases. So happens with the density, which also increases, and the increase in density make this cloud to collapse and form a protostar. So the answer is when internal gravity increases, the temperature and density of the cloud increases and the cloud collapse and form a protostar. Second question says describe and explain what happens as a protostar become a stable star. So for example, this blue ball is a protostar. Now there is a fusion reaction occurring in the protostar and in which hydrogens are combining to make helium, and the temperature produced is making an outward force on this protostar, and there is also a gravitational pull of the star which is acting inward. So whenever this outer force and inward force are balanced, the star becomes stable. So the answer is due to fusion in star, the temperature increases and outward force occur. When inward force due to gravity is equals to outward force, the protostar becomes a stable star. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.